Okay, so let's continue system design. So today I'm going to talk the one of the most basic part about the system designs is that whenever designing any system, generally system have a basic components. So one components use a software system, okay, which are process, maybe request, maybe data, something. So your actual software component which are responsibility to receive this customer request, receive the API request, receive the some kind of integration request and do processing. And once processing done, they generate a response. It's okay, but sometime they receive request and generate data, and they are going to system is also going to persist somewhere, store somewhere for the next times. Let's say you want to get user profiles are maybe created and returns. Next time again say, hey, this is my user profile. They're not going to generate again user profile. Somehow your user profile records or data information must be stored somewhere. That is a permanent storage device. So I'm talking about the where your process data or requested data are stored. Okay, so storage mechanism where your informations after processing done, after filtering done, where your information going to store. So that's section known as a storage system. So these informations are stored, and later part again next customer request, you can just retrieve this information again and return back. Again call, again retrieve and return back. So the while your system can generate data and response, that's good, but apart from that they can also going to store, persist, permanent storage device. So that is known as a memory location. So in computer system there are a couple of kind of memory systems. One is a permanent storage system, that is we known as a hard disk, where all the informations are going to store. And also couple of memory, you can say some memory are used by our system software, also our operating systems also. So some memory that's required to process your data is required. Somehow your RAM read-only memory, where in this memory our system can do the processing. Okay, because means processing any instruction required some kind of a memory. So there are a couple of memory. They have some registers memory, RAM memory, some also some fast access memory like L1 cache, L2 cache, L3 cache. So lots of operating system level of memory here. And after that we also have a couple of our own cache systems. This is also one of the key concept, where you are retrieving data again and again, the same data. Why not you put inside your system again, that cache the data, store temporarily here on something someone demand and request. So this is the cache memory. And later part, if everything done, then you can store your permanent device, maybe your C drive, D drive, hard disk, tape drive, anywhere you can store. So this information, generally when we talk about the Windows machines or Linux machine, they have a file system. So your information generally going to store some OPT logarithm folder or OPT CDN or C drive or D drive specific folder you create, and your all the informations are going to store. This is good part. So all the operating systems provide the all the programmings, whatever the programming language you're going to use, they provide to use the file system. File system is how you can create file, how you can write data in a file, how you can read data from file. So this mechanism file system is fine, good. So initially that makes sense. If you have a little bit information you are going to just store in the file system, you read, write, you know the file handling, okay, that's great. But whenever you going to talk about the real applications where the number of read and the number of write is very large and frequently, and standards, not just simple text message you are going to write, you are going to write some standard object or some well defined structures. For those scenario, the file systems is not so efficient. The file system is so efficient, but the developer, each developer or the software engineer is not so capable to writing such code, to reading or writing a structured data, non-structured data in a proper manner, the relationship, everything. So that required lots of effort to use file system to maintain the to response the customer request. Hey, you create the customer profile with the customer ID, name, email, address, mobile number, contact number, ABCD, everything, and all informations are stored in the files. And later part, you know, I want to each employee the email number. So for those, you are reading 10 lines from the 10 different file and extracting only the email addresses is very tough for the in general not inexperienced file system developer. If anyone who has very experienced, intelligent to write enough best code to reading, writing, manipulating, querying, grouping in the file system, is it sufficient for him? But nowadays, with keep in mind, every developer, every software engineer not so capable to manage file handling, file processing. So we are using the inbuilt software. So instead of we are going to the build all the file handling file systems, we are going to use the inbuilt software that is known as a database software. Okay. So in the market, lots of database software available, and each database have a different purpose, different use case. So in this lecture, we are going to start how we can design our database, how we can choose our database. Database is just a software. Be careful. They are internally, whatever database software you are going to use, they are internally use your permanent storage location, C drive, D drive, / temp directory, OPD directory, any directory. While installation software, you have to give some space, and those softwares are going to internally store everything for you, and whatever the basic requirement you need, they offer you. So like you are building one system for the customer, similarly already database is one software that built by company, we are using them. So while designing our systems, we are many places going to use the existing software, existing library, existing systems. So here, for your persistent, for storing your information, for further access, further use, we are not going to write any kind of file handling programs. We are, instead of writing the file system code manually, we are going to use the inbuilt software. That software known as a database management software, DBMS, database management systems. And we already study DBMS in our syllabus, our course, our colleges. Okay, so we are familiar what is the databases. So I'm going to talk basics, some basics about the database, what the data, what the database, and what the types of data, and couple of you can say classes we are going to discuss this database system. The reason is that in the system designings, data is a very crucial and important for the customer, because your whatever the system designing, they are finally going to generate data, and whatever the generating data, you are going to persist for 1 day, 1 week, 1 month, 1 year, decade, lots of, and after that you have to provide the systematic mechanism to read data, get data, aggregate data, summarize data, right? Customer next, after they ask couple of questions, couple of query, you have to answer them. So while designing any software systems, please be carefully design our storage systems, selection of database. Okay, and what happened, you have to think, initially you have a limited data, and what happened after your data size is going to increase, how you plan to backup, how you plan to recovery, what happened your system somehow crash, shut down, and how your system ensure that the data they are going to preserve, they are going to persist it. So lots of feature about the database management system we are going to talk and we discuss. Okay, so please be clear, whenever you are designing any system, your storage of information is very important. Okay, so let's think how we can go in this direction. So let's talk basics. What do you mean by data or informations? Okay, so if you talk about the theory definitions, so anything you can data, anything set of facts, any facts or any measurements or any observation that can be recorded, that can be stored, that can be processed by the computer. So if our computers can record, can store, can process what, any facts in my life, whatever are any measurements, you are calculating something, or any observations, I am sitting and observing something, maybe humidity measurement, maybe air, maybe water pressure, maybe air uh, 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 labels, or any kind of observations, maybe whatever you're talking about the product, you are talking about the customer, my personal information, my banking system, my medical detail, my financial details, any kind of things, generally everything whatever we have, generally all are the facts or data or informations. Okay, so why here mention record means our system can read them. Record means our system can read those information. Okay, so let's talk about the natural resources. Maybe actual, maybe air. Air is not read by my computer, but about air, about definition, about pressure, about air, actual things are not read by my computers. Please note, whatever the computers are going to read, store, process means generally about, let's human being, I'm human being, so computer is not going to store to me, but about my name, about address, about my details, about financial detail, about the personal detail, about the medical related details, the about things. So whatever the in our universe, whatever the object we have in the computer, we can store about related informations. Okay, so please be, so any informations as a human being you observe, or any machines that can observe, or any animals, or anything about the nature, whatever we as a human beings are observe, see, listen with our five organ senses, like whatever you can see, that we can request to record our system. Whatever you can listen, we can tell system, hey, this is the information we can listen, you can store them. Similarly, what we can smell, what we can taste, what we can feel from our skin. So whatever the human body have a 5 organ sense, your eye, your nose, your tongue, your skin. Okay, these are the eye, nose, tongue, your skin. Okay, these are the your organ sense, and in this case, whatever you observe, feel, hear, you can hear from ear. Okay, everything. These are the 5 organ sense. So those about your sensing organs, you can request, hey system, I listen something, I saw something, I hear something. Related information you can store. So similarly, so those are a set of facts, like facts maybe sun, lots of planets, sun, you can say earth, you can say moon. So about, we can know our earth size, our earth rotation, earth, what kind of parts earth have, what kind of a percentage of water, what kind of percentage of lands, everything you can say related facts are some measurements. Hey, how many number of humidity, temperature, speed, everything. So all the, as a human being, what we observe, okay, we are going to about related information, say computer can store. So anything that can be recorded are processed and saved. So here, once whatever the information you are listening, okay, you are process them. Process means make one meaningful, senseful information and then store. Okay, so store database. So here, whatever the general information, maybe raw information, unnecessary information you can receiving. But our systems, whatever you design system, that system make a systematic way. Like you notice as a simple rule about the English, we have lots of words. Okay, the words, whenever you arrange these words in a systematic manner, that make a one meaningful. That is become a sentence. So you can say sentence. This is a sentence. If we are arranging just a word, and there is not any systematic order, might be we cannot get any meaning. You cannot sense the meaning, important about the data. So process means our systems are receive lots of user information. They are going to rearrange in some specific manner so that this information become meaningful for our customer, for our client. So all the system designs, the objective is your process. Process means rearranging your information in a such a order that make meaning, that serve a specific purpose. Be clear, whole software systems is just designed so that whatever your information customer had, same information just our system receive and do some kind of processing, make some, here in the case of English grammar, lots of word we receive, but as a rule of grammar, subject, verb, predicate, object, lots of things, and we according to the grammar we place those words in a such a manner, this someone read this word, they can read but not make any sense what this is saying. But same words, we are with the help of English grammar, you arrange such order, same information become meaningful. Similarly, lots of customer, any kind of random data, any kind of information you are collecting, might be we human being cannot understand the meaning. So our system too, with the help of some lots of permutation combination, they generate very inside meaningful data, historical data, aggregation data. Like, hey, like nowadays, lots of temperature data, raining data, humidity data, daily basis we are going. But on the daily based data, we cannot mix any kind of observation for today or tomorrow. We cannot predict something. But if we store all this information and make some specific rules, regulation and patterns, and then system observe. Nowadays our scientifics, maybe medical science or any science, existing data, existing facts, our system can predict. So similarly, we are designing the such systems. Whatever informations we have collect them, we have stored them and process. After processing, we make much value, we make meaningful, we make a sense. That process information help us to meet the customer need or business requirement. Hope it's clear what do you mean by record, store and process. So all these things are the data. Okay, that's good, that's very good. Now let's talk about data in computer science. What can be, what the form of the data would be. So if you talk basic about the form of data, generally we, since college, we have learned mathematics, lots of number system, might be in an integer number, float number, decimal number. Might be we learn English language, maybe one word, maybe one sentences, maybe one phrases, maybe one lots of things. Data can be text. Nowadays data can be images, your photographs, your graphics, your painting, even your video, audio, everything. You can say audio such as a sound or voice, everything, video recording, audio recording, sound recording, all are the data, all are the information. Even about the date and times, all your date, all your time, all your milliseconds, all are the informations, all are the data. Okay, so generally maybe other category can be, but in generally these kind of data you see in your computer, maybe number, maybe text, maybe audio, maybe video, maybe images, maybe graphic, maybe painting, so maybe date and time. These are the informations. So these are the information generally our system capable to store. Yes, can store. So if you categorize overall data and the types, what kind of these are the data, maybe how these data structure, means ki some data can be classified in the different types. Maybe here, maybe one of the structured data, semi-structured data and unstructured data. So generally in complete our database systems, we have categorized structured and non-structured data. What do you mean by structured data? Structured data means highly organized and follow the specific format such as a table, spreadsheets. Yes, means ki structured data means let's see employee information. So we know we are going to store employee ID, employee age, employee name, employee salary. So these are the very specific set of data you are going to the capture. So this is known as structured data. For each employee, we are going to store this information in the company. So here you know every attributes, and while going to storing data, we are going to store for each and every attributes. So this is known as a structured data. Semi-structured data, data that has some level of organized but does not rigid format, means ki number of fixed row not. So just like XML or JSON, maybe you can define one XML have a generally JSON have one key and one value. We have another key, might be they have a array of value 1, value 2, value 3. Might be you define one JSON key, and in this JSON again you define the JSON key and again value. So notice here key and value, key and different value. So your structures of data are not fixed. Maybe someone only one value, someone array of value, someone a set of again key values. Similarly for XML or JSON, these are the semi-structured data. Somehow they have a no these kind of key value, attribute and value are going to store, but in the different variation, different each key have a different kind of values. And some kind of last is unstructured data, where we don't know exact what fields attribute we are going to store for this information, what attribute we are going to store for the another information, maybe. So lack of predefined format or organization, such as you talk about the image, talk about the photograph, talk about the audio, talk about the video. These all information considered as your unstructured data. So whenever you talk, we are going to store this information, persist this information. So for each specific kind of data, we have a different database systems available. So for structured data, have different kind of database. For semi-structure, we have a different kind of database. For unstructured, we have a different kind of database. So according to the nature of data, classification of data, we are going to choose. While system designing, this database is fit for us. So whenever you're talking to your customers, you have to understand the nature of data customer has. They have a structured data, they have a semi-structured data, or they have unstructured data. And depending upon the data classification, you have to select your database. So Tom, what is the database? Till now we discussed about the data. So what is the database? Now database is one of the inbuilt software, okay, that provide mechanism to storage, a collection of data that store the way the efficient retrieval and manipulation. Means ki this the software systems, they collect your data and store somewhere, storing a very specific manner. Later part you ask, hey, I want this data, give us, they give quickly, they give immediately. And if you want to, hey, I want to modify some data, I want to update some data, they quickly figure out, oh, this data I want to update or modify. So this is the one of the database, is the one of the inbuilt software system. They provide a way where you can request, hey, this is my data, set of data you can store in the system. So they are using the internal, they are using the file systems, whatever the file system, they are going to storing for you in a systematic manner. Okay, they follow the some specific way. That means ki each database have designed some specific algorithm, the way they receive input, the way they are writing data, and later part you want, hey, I want to all the employee name, they give you. I want to all the employee name and particular email address. Yeah, I want to find all the duplicate employee. Such kind of query you ask them, and the systems, database system easily, fast, quickly reply them. So due to that, we are not going to write file system manually. We introduce the middleware. This is the database, is the one of the software component, and we use the database software. System designer use the database because customer don't preferable. We as a system designer responsibility to select which database software we are going to use for my system. The database is nothing, inbuilt systems, inbuilt software that provide the mechanism so that whatever your data information have, they can store them and a specific way, and later part you ask, you run the query, they return efficiently, return and manipulation. Both options they give. Okay. So let's talk about the database. Also have a different kind of variety. Maybe someone flatly store some flat file, or maybe some relational database, maybe some object oriented databases, maybe some graph database. We are going to talk detail about this variety of data and corresponding different kind of database systems we are going to use. Okay, so if you talk categorization of database, like here say, so highly database, I'm going to talk about the relational database or non-relational database. Okay, couple of decade before, you can say, only initially we are just using the relational database known as RDBMS or structured query language, you can say. and after a couple of decade later part, nowadays with the advancement of the technology, the way we are generating huge number of volume of data, so we are going to use the non-relational database as well as. So sometimes a SQL database and sometimes a NoSQL database, and surely we are going to talk each every kind of database further, but you should aware like one kind of database is the RDBMS relational database we're going to talk, and some other non-relational database like maybe key value storage, maybe document oriented, maybe column family database, maybe graph, maybe time series database. So these are the different kind of database software systems available. These are all are the software systems, inbuilt software, inbuilt systems. Just we are going to use them. We are not going to design them, but for every database we know what the specific purpose this database is designs, what are the key feature of this, what are the advantage of this, what are the limitation of this system, where we can use this system, where we cannot use this system. So all these are software systems, they have a well documentable labels. Just we read out and understand each database, each types of database, what are the database, why use, what are the limitation, what are the advantage, so that according to the customer's requirement we can select and we can fit. Okay, so let's talk first one, relational database. What do you mean by relational database? You can say relational database, or you can say RDBMS, or you can say SQL. These are the same terminology, right? RDBMS stand for Relational Database Management System. That means this is one inbuilt existing software system that are built by some other organization, some company. And notice whatever the software, database softwares already exist in the market, some are the open source and some are the paid version. If you are going to use, you have to take license, you have to purchase them, or we have to pay something. And there are some database open source, free, just use them. So you have to also consider while going to choose the database software for your system, that may cost. But please ensure if some software are freely available, it's good. Some software, same database software available with the paid, what the difference is? Means something additional this software offering other than just storage and retrieval. Somewhere very critical information, secure information, you don't want to lose any kind of data, something, some additional benefits. So might be some customers don't want to compromise something, they go for your paid version of operating systems. Some are the very good, no, let's go with the open source freeware software. So you have to aware whatever the relational database you are going to choose, because they are going to the serve for the couple of years, not just 1 year, just 2 years. Let's you select one the paid software, and every year you have to pay such amount, and last 1 year, 2 year, 10 year, 5 year, 30 year. So you can calculate how much cost we have to pay for the specific feature. That specific feature is offered by the paid database software. So while system designing, we have to consider the long-term vision of the customer as well as while choosing the right database. Because in the market, in the industries, dozens of database software available. I'm going to talk couple of, but not all. Different use case, different scenario, different situation, different kind of database available. Okay, so we should be aware. So here I'm talking about relational database, where it is the database simplest. Each generally RDBMS database are we read in our college school. This is the very simplest way, easiest way, type of database management system that store data in the structured and organized way using the tables and well define the schema. So here relational database RDBMS, they are going to store information like a column format, row and column. They create column, this is column, and here column means your schema. First you define a schema. Schema means your employee ID, employee name, employee age, salary, address, everything. So these are specific your column name. Okay, this is known as a table. Table can define your table name is your employee table. They have a couple of database column. What are the types of values? ID, name, integer, float, double. What kind of data they are going to store? And according to this employee one, whatever the employee information are going to one row. Hey, employee ID, employee name, age. Second employee, second row are inserted. Third employee, third row are inserted. So each row represents the one object. That is the employee object. Okay, so this is the well defined. This is known as a structured data. We already decide for employee these 10 information I am going to store. So every employee I am going to ask you this 10 information I am going to store. So these are the very simplest and very powerful. Still they are the very old kind of database. Still very places we are still using RDBMS database. You cannot say this is the oldest in the college level. In our system we are studying RDBMS, so we are not going to use the application. We are even the relational database. You find the both kind of database. One is the freeware software, one is the paid software. We're going to talk because yes, we should aware. And sometime these offer to store these informations and for retrieving, for asking question. Hey, all my employee informations are stored in your database. It's good. Let's see 10,000 employee information I will store here. Now I have to ask some question. I want to give all the email of my employees so that I want to send a notification. So how we as a human being going to ask question to the database softwares? So those languages known as SQL, structured query language. So we just say, hey system, I want to find all the email of my employees. So it's just some standard SQL language. So you say select email from table. So you are getting all email from your database table. So very English driven language. So this is the database specific language. You can say structured query language means that RDBMS use. So you can just ask question, hey, question in the form of SQL query. So due to that we can say relational database RDBMS or SQL both become a synonym. SQL for structured query language means you are asking using the standard English language to talking to this operating system software. So these operating system softwares are designs in a such way that are generally used by the IT professional like a system engineer, software engineer, database administrator, IT person. This software like relational database software is not designed for the customer, not designed for a end user. No, these have a very standard language that's used by learned by the engineer, so that engineer can talk to this database. So whatever the relational database we are going to use, we have to learn some specific language, structure query language, and this help us how you can say, hey, this is my data, can you store? We have to ask this question in SQL language. If you want to, hey, I want to average salary of this month of my employee, or what are the max, who the employee are getting the maximum salary. So such query, how you can ask to the systems, you can use this structure query language. So RDBMS or SQL are the both are the same things, just different way. Okay, so there are some couple of features if you are following the SQL databases, like normalizations, relationships, integrity, and ACID compliance. These are the very key features which only this setup. I'm not specify all the features of SQL database, but these are the four very basics and very important. Due to this, the particular database which not offer these features, you can say this is the NoSQL database. One is standard normalization. What do you mean normalization? Normalization ensure that each piece of data is stored in the only one place to minimize the data redundancy and improve the data integrity. So here say, let's say employee name. So here employee name you are going to store only one places, not the different table. They required employee name, you are storing here employee name, in this table employee name, in this table employee name. So if you are storing same information and multiple places, are duplicating those, extra effort and some kind of in future problem. Let someone modify this table data, these are true still unmodified, the data inconsistency problem you can found. So normalization ensure that one piece of information are stored only one place, so that you are not going to duplicate. And if you are minimizing the data, as less data, as fast you can do retrieval, right? And one thing, the relationship. So once you decide the multiple employee table and customer table, department table, calculated, so according to the your related data, related tables you created, and now these tables make a relationship. Maybe relationship already we have to call one-to-one relationship, maybe one-to-many relationship, or maybe many-to-many relationship, or many-to-one relationship. So these are the kind of relationship: one-to-one, one row to another row, one to many row, many to one row, one many to many row. So all kind of relationship this RDBMS SQL database support. Okay, so allow to be linked across multiple table. Or why this relationship? This relationship help us to make very complex query and data analysis. You want to analyzing data, you want to make a relationship. If there is no relationship, couple of different tables is store data, you are not analyze those data. So for analysis, for getting the some conclusion for those data, we need a relationship. So RDBMS database offers, and they ensure some level of integrity, enforce rules and constraints to ensure data consistency and accuracy. Let's you have defined the table name, age, and in age is the number. So you can put some employee age the 81, some 800, some 8000, all of the number. Is really valid employee age? No. Our systems ensure that hey, our employee age only greater than 18 and less than 16. So such constraints are rules you can apply on the database table. Hey, our age column is only stored greater than 80 and less than 90. Those constraints are checks you can apply. Even say this is the only contain text, not the number. This only contain number. This only contain Boolean value. Okay. So for those all the integrity checks SQL database software offer. And one of the key feature about the ACID property. So ACID, that means atomicity, consistency, isolate, and durable. So I'm going to talk about the generally any database that provide this ACID compliance guidelines. You can say this is the one of the key features of your relational database. And nowadays, whatever the NoSQL database in the market, some of the principle they are not following. Okay, like maybe normalization, relationship, integrity, or ACID. So let's talk about the ACID data, because this is the very key features of relational database. And if you aware ACID, you can think similar kind of features might be some NoSQL databases not offering. So these are the very high level key features: normalizations, relationship, integrity, and ACID compliance. If any database offer these, there are a couple of lots of SQL database features, but I'm not going to discuss, but you can look out the documentation. But yes, SQL database software offer these features. Great. So let's talk about the ACID detail, because these are the one of the key features about our database. So in ACID, that means this is the fundamental concept in a database system, and ensuring database transactions are processed reliably and securely. What do you mean by transaction? So new terminology. Till now we understand the store, retrieve, manipulate. Means we can store data, we can read data, you can update data. But what is the meaning of transaction? So whenever you are going to run SQL query, and a couple of SQL query you can run: SQL query 1, SQL query 2, SQL query 3, SQL 4. They are storing some data, they are storing some different data, they are storing in different table, they are storing something different. So this something are your make one transactions. Maybe here you are withdrawing money, you are depositing money, you are updating your journal, and you are updating your profile, customer profile. So all these are the one specific use case, one specific transaction. Transaction means you are going to execute couple of SQL in a one fashion. Okay, so those transactions should follow this rule. Your transaction must be atomicity, consistency, isolation, and durability. We are going to understand each and every by the example. So here, ACID property or ACID compliance, whatever the database transaction going on, those transaction database must be processed reliably and securely. If your transaction follow this atomicity, consistency, isolation, and durability or not, let's check. So what do you mean by atomicity? So as name suggests, atomicity. What do you mean? Here say that whatever database transaction you treated as a single unit. Okay. So here say, okay, let's SQL transaction 1, 2, 3, 4 SQL query you are going to run. So you can say as look like you are running 4 SQL, but atomicity say, hey, let's consider it is only one unit. That means this one transaction is success or one transaction is fail. If this transaction going to initiate in database, so they can do all the 4 items whatever they requested, or they done nothing. Let's get they done 1, 2, and here problem 3rd, then they again roll back. So here these 2 committed to change data also roll back, undo you can say. So whatever the previous state before transaction is start and after failure, they would be the same. So here any part of the transactions fail, entire transaction is rolled back. The database return into the previous stage. So this is the basic rule. If I fired one transaction have a let's couple of SQL and couple of different database you are going to update, modify, and if everything success, it's okay, transaction is success, no problem. For the success scenario there is no problem. Only problem if what happened, the particular one transaction is fail, not success, all the successful transaction also you have to roll back. Your data should be the previous stage. So this kind of feature the RDBMS database offer. So this feature ensure the database remains in the consistent state even the events of error or failure happen. The atomicity say if any transaction you start, they have a couple of statement, in any statement fail, completely roll back. your data should be look like a previous state, not in this state. Okay, so good example here given. Imagine you are transforming money from one account to another account. So atomicity ensure that both accounts updated correctly. Neither account is updated not to maintain data consistency. Let's say this is the account 1, this is the account 2, right? Here you have a withdrawal, let's say 500 rupees, 500. So here must be appended 500 plus. Okay, here that not the case. Here you withdraw the money, but here you're not going to update the money. So this is the data inconsistent data loss problem. So by default, relational database such kind of atomicity offer. They are ensuring that whatever transaction you are initiating, they can consistent. Let's talk about the consistency. What do you mean consistency? Consistency ensure that database remain valid, still adhere, define the rules and constraints. The database must ensure data is correct and conform to define the schema, constraint, trigger. So whatever the data you are storing, let's like employee name, and this employee name you are maybe storing the couple of places, assumption 3 table, and someone going to update their employee name here something, and they are something missed to updating these two information. If someone reading data from this table, they are getting some different name, as someone data reading from this name, they are getting some different name. So this is the data consistency problem. This is the one scenario. Second scenario, let's see, I am going to update the amount. So let's we have a 3 view my amount. If let's see, I am going to updating my amount here. Let's say initially amount is 100. I am going to I'm updating amount 200, right? So here 200 were updated. If every times every view are going to read and always get a 200 updated value, that is your database is consistent. What happens? Someone read and find 100, as someone read find 200. This is the data inconsistent. That means ki whatever the database, if any point of time multiple requests come, each request get the latest and updated value. It is not a scenario if some requests get the different value and the same request get the different value. So such database is known as a consistency. Let's we have a join maybe ATM or some cards. If I am going to check my balance, I am getting X amount. Similar same time, maybe my wife are using the same cards, and if she checking the balance, should we check the same balance both sides? Maybe she is withdrawing, I cannot withdraw more than that something. So something ensure that whatever the read happen at the same time, multiple users are requesting for some data, you have to ensure data should be written the same. Good example here in the banking system, consistency ensure that the total amount of money in all account will be always be equal of the total amount in the systems. Okay. So these are the all the atomicity or acid property is very important in the financial application, banking system, stock market, where the finance, where the numbers matter, consistency matter. This is very important role play. So let's talk about the isolation. What do you mean by isolation? So here they ensure the concurrent transaction. What do you mean by concurrent? Currently, let's one transaction come, it's okay, they are doing some updating database. This is my database system, they are updating. The same time multiple transaction can be initiated. Maybe they are going to updating something, they are going to also updating something, they are going to also updating something, and this is the one transaction, this is the one transaction. So here say whenever concurrent means the same time multiple transaction initiated. So one transaction, whatever the data, so they are going to updating some record. So this updated record is not visible to this transaction, because till now they have a still in the transaction. Maybe this transaction success, this is a failure, that can be again roll back. If this is rollback, they are reading the older data. This transaction can be the old data. So what the scenario means, that means each transaction are not able to access the another data until they are not successfully committed. If this is transaction successfully committed, and after that this transaction read the correct value, until transaction is open, one transaction, one request data, another request data cannot be visible. So here say concurrent transaction do not interfere to each other. So whenever two transactions is happening, both are not able to see data to each other. Because why? What's possible? Because both are writing in the same database. If database is shared, they are also writing. There might be chance this is can read the data. Till now this transaction is not committed. They can go and read the same data. So this concurrent requests are ensuring by the isolation. So maintaining illusion of serial execution. So each transaction operated as if only transaction has been accessed. So ensure that if the particular transaction going on at that time, another transaction cannot view or see or update the data. Once transaction done, success, and later part data can be visible for the every transaction, not the only every user, every request. Example: multiple user trying to look the last available seat on the flight. So isolation ensure that each user transaction is processed independently without interfering the other one to prevent the data inconsistency, right? So here example, like we have a number of seat. So here is a, let's say, number of one seat. I mean, multiple users are maybe, hey, I'm going to the book seat. So they are going to the book seat, they are going to the book seat, they are going to book seat. So at a time checking data, hey, one seat available. So whoever now concurrent transaction is started. So until they are not committed, is it not allow, hey, this is also book, this is also book, this is also book. The some level of isolation is also required in the case of concurrent. So ensuring this database, ensuring that data is the valid and valid user can proceed. Okay, so these are the kind of isolation feature. So last not least, but it is the durability. What do you mean by durability? They are ensuring that transaction has been committed, its effect permanent and survive even system failure or crashed. So here, let's now, this is our database. Okay, one transaction is started. They have a couple of queries start. They are going to do this, they are going to do this, they are going to do this. They are going to do this. If this is the failure, all the rollback, that's okay. But what happened all of the success? This transaction say, hey, this transaction is success, and they inform customer, hey, transaction is success. And between success, what happened? This database is going to crash or rollback or outage or something. So how our database system ensure that anything happen, if one transaction say I committed successfully, this data must be available, persistent for the system. So here, after transaction has been committed, durability ensure the changes written back to the disk and persisted even the system crash or shut down unexpectedly. So here there is a terminology used in the commit logs. Somehow, if transaction is committed, whatever they are going to somewhere maintain the log file. If something is crashed, and then again you restart database, this commit logs again going to committed in the database. Once database server up, you can see those changes. So multiple level of complex algorithm and logics implemented. Commit log label, transaction label, right now. So in how you can say this RDBMS database ensuring that the ACID complies all the ACID property like atomicity, ensuring transaction treated as a single unit, consistency, ensuring the database properly not you can say duplicate or inconsistent. Each read must be get the updated one. Let's keep 10 millions of read continue come on the 10 record going to read a particular row. Each row each times get the latest and updated value. Isolation, that means whatever the concurrent request going on, they are not going to interfere in each other. They cannot see or update, read data from other transactions. Durability. If any transaction is committed, our system ensuring that they are preserved and available even our system failure. If any database is compliance this SS property, you can say we are selected right RDBMS database. For example, let's here if you talk the relational database, lots of relational database concept here like MySQL database, Postgres database, Microsoft SQL Server database, Oracle database server, B2Do, Microsoft Access, Firebase, SQLite, lots of database in the form of relational database. All are ensuring that they are offering this relational database feature like normalization, relationship, integrity, ACID property. All general relation database maintain the data in the particular tabular format. They create one table and multiple, for each table have a column and all the data is stored in the particular row. And these are the table row column concept, and all are the database support kind of key. Key means your identification, maybe foreign key, primary key, candidate key, unique key. Right now, some data you want to make a one column should not contain duplicate data. You can make duplicate key, and these define a schema, what the table should be, what the field should be, and SQL language means how you are going to talk to these database softwares. And these already talks about the advantage like these follow the RDBMS rule. So you have not the only normalization in your relationship ACID property, but 12 rules you can feature. I'm not going to talk all 12 rules. If any database is following 12 CORDS rules, you can say this is a relational database. And by default, this relational database, if you are discussing your application designing the structured data, you can take the advantage of relational database, and you want to efficient query, quickly response, and you are going to take response from the complex joining, complex query, multiple relationship. So, and that ensure the data integrity, consistency, and one level of they are providing the secure data. So here couple of open source software, couple of like this is a license based. This is some open source. So you have to identify which database you're going to selecting, database software you're going to select, and that either open source or freeware, yeah, paid version. You have to buy the licenses for using the productions. Okay, so these are the relational database, lots of relational database, both in the form open source and non-open source. So you have to study both open source, what the feature. No. So let's say about this kind of open source database. Somehow I miss. Okay. So whatever we talk, that's about relational database software. That's our your software that's are open source, software that's are the non-open source paid version. Like this is the Microsoft paid version software, Oracle paid version software. Okay. So if you compare the performance, lots of additional benefit this paid software offer in the case of your long-term support. Maybe they are asking also long-term support, 1 year, 2 year, whatever your database volume is going to increase, high number of increase, storage size increase. So if something happen, this company offer support for you. If you are using like MySQL or Postgres open source, you have to manage yourself. If your data is used, how to scale them, how to index them, how to sorting, lots of feature. Later parts we are going to talk one or the more how to scale data. This RDBMS database, how we can scale them. If our load or data going to increase. Surely only one database, only one instance is not so. So in the later classes we're talking about the scaling, maybe vertical scaling and maybe horizontal scaling. So here relational database generally go to your vertical scaling, and after that we some concept apply the your sorting. So we'll talk later vertical scaling, what is the sorting. These concepts are very useful when your data size is going increase daily basis. Whenever your table contain the number of rows 1 200 3, they quickly response data, but your table size is going to increase, they are, yeah, query response is going to too late. Okay, even your writing data is too late. So lots of things, we will not discuss everything here, but you have to, this is the basic concept you have to look. So these are the all of the advantages. Let's talk something also have a problem. Every software, whatever you are going to select, you just look the both. Every software, let's keep the RDBMS database selected. So what are the key benefits we discussed? That's good, but there are some couple of challenges, couple of problems also. We should aware both. As a system designer, don't look just only one view of any software. What are the key feature where you can use? That's good. What are the problem? What are the bottleneck? What the situation system is not work properly? Might be the use case we are discussing. So as a system design engineer, we have to look the system in both way: success scenario, failure scenario, small data set, huge data set, advantage, disadvantage. Similarly, this the relational database also have lots of limitation. I'm not going to talk, but majorly scalability, rigidity, and unstructured data. Relational database not support your unstructured database. Due to that, NoSQL database we are going to talk. Okay, generally this is RDBMS is not designed to store any kind of unstructured data like images, video, song, audio, something. No, if you are storing, they can support in the block format, but it's not so efficient. Okay, rigidity means whatever the table you are going to decide, initially you have to decide the fixed column, and that's very flexible. Some let's say initially you decide the employee table contain only 5 column, later part you want to 10 or 12, that's make lots of difficult to change the schema, right? We have the option to alter table, but again all the existing record you have to also update something, right? So this is the one of the rigidness, fixed number of column, fixed number of attributes. Initially the database designs are going to support, and scalability. The major flaw, the problem nowadays with the RDBMS is to become a bottleneck for the data set grow. Whenever your data growing, after a couple of years, you observe that your system performance, your SQL server software, whatever you're using, the performance is going to degrade. They are not responding data as quickly as they want. So here problem about to scaling is how can scale my system. So at the RDBMS database you can vertically scale. So whatever software you are using, here you can increase the RAM, you can increase the memory, you can increase the capacity, you can make the very powerful machine. Vertical scaling easily happen, but it is very difficult to make horizontal scaling in the case of your relational database. This is the key benefit, this is the key drawback in the horizontal scaling for the RDBMS database. Same advantage you will discuss in the NoSQL database. They are easily scaled horizontally, but here RDBMS, if you're going to scale, you can vertically, means you can increase the RAM size, registers, memory, cache memory, means only one bigger powerful machine. Scaling means whatever the software currently you are using, maybe 2 GB RAM, let's say 10 GB RAM, let's say 50 GB RAM, you can make a powerful machine. Means one machine with very powerful capacity, long memory, hard disk you can increase. That is known as a vertical scaling. Horizontal scaling means you can increase the couple of machines, software machine 1, machine 2, machine 3, machine 4. Okay, so these are the basic drawback about the RDBMS. Whenever your data set is going to cross the particular limits, relational database performance is going to degrade. Else, if you're designing system that's work for the limited data set, relational database is best choice. Don't go with any other database. But you think after discussion with customer, the number of agreement, the number of year your software going to survive in the market, you have to always talk data set. How much data you are going to manage, store, retrieve, update, aggregate query. I want to embrace some other aggregate function. Those functions perform very slow if your data set is going grow. So due to that, if you have a larger data set, then go with a non-relational database system. We're going to talk later. But these are the, for the day, we have to consider to understand if your customer requirements have some kind of limited data set and you want to maintain the atomicity kind of feature, like database transactional level of atomicity, like a insurance domain, like a financial domain, like a banking domains. In those scenario, RDBMS database is the best choice to use. And some non financial domains or application, like a gaming system, maybe movie system, song system, some bit of data up and down happen, no problem. Some kind of consistency you can compromise, and huge data set you are going to maintain, then you are going to the non-RDBMS database. But please ensure if your this database selections, RDBMS or non-RDBMS, SQL or NoSQL, is the data nature. What kind of nature of data? What kind of a data you are going to the serve? First point, nature of data, and second point, the volume of data. How long, how much data you are going to process and run. If you are huge volume of data and non-structured data, go to the non-SQL database. But you have a limited data set but structured data, then go with the relational database. Nowadays, paid relational database also provide to manage some huge data set with the help of scaling, maybe vertical scaling, and some kind of sharding, some kind of a master slave database. Lots of things available, which are the paid software offered to you. You have to explore. If you have a only working on structured data, but some data set is going to increase, you still have a option how to use the RDBMS. So RDBMS, some places are really must have to use, and some other places where you can use the NoSQL database. So we're going to talk more in the NoSQL in the further classes, but today you understand where, for which kind of data is structured data, limited volume of data, we are going to use the relational database. Relational database means we are going to use the existing software in the market, maybe paid open source software or freeware software. Okay, and depend upon your customer agreement, you are going to use the freeware software or the paid version of software, licensed version software, and accordingly they offer the different capacity, different features. So let's think data is a very crucial for any customer. How you manage data, don't go in your own skill like a file system. Let's use inbuilt standard database management software like MySQL, Postgres, SQL Server, Oracle. Use this, and all the benefit of a relational database feature you can get automatically. You have don't do anything, just use the existing RDBMS software. That's for today. Thank you.